Start recording. Hello, this is TG7. So our assignment topic is video streaming with the RTSP and RTP. So what is the real-time protocol? Real-time transport protocol. So RTSP means real-time transfer protocol. So what is it? So the real-time protocol is a protocol is designed to handle real-time traffic of the internet is known as a real-time transfer protocol. RTP must be used with UDP. So some application of RTP. RTP mainly helps in media mixing, sequencing and time stepping, voice over internet protocol, video teleconferencing over internet audio and video streaming. So the real-time protocol streaming RTSP. Real-time streaming protocol RTSP is an application level network communication system that transfer real-time data from multimedia to an endpoint device by communicating directly with the server streaming the data. So here the picture. So the client request HTTP GET to the web server. Now web server reply with the session description. Now the client request for the setup and then multimedia server will reply back. Then client will request play. Then multimedia server reply. Then multimedia server replies with RTP audio and RTP video. Then RTP can then client can also make a request for play and close for the server. So this is all about the real-time stepping protocol. So now we move to the code part. So here's the demo. So first we run the server side with port number 8000. Now for the client side, we choose localhost, server port address, then RTP packet port number and the file name. So as you can see, the setup is making request and we get the message at the client side. Now we play and pause and all the things is working fine. We are able to get the sequence number, current sequence number, play, pause, tear down, not responding. Choti. नहीं यार
રેકોર્ડિંગ થાય છે ને ગરમ થઈ ગયું છે
રેકોર્ડિંગ તો થઈ જાય
180p માં જ કર્યું છે કે વધુ છે
એટલે હા લે
વધુ હશે તો થતું હશે
વધુ
ટર્બો માં સ્પેન ઓલો નોઈઝ આવશે વધુ પડતું નહીં એ તો નીકળી જશે પણ નીકળે
ક્લોઝ હવે અરે ભાઈ સાહેબ
શું પીસી બંધ કરી
ના પીસી નહીં
તો રેકોર્ડિંગ પોઝ કરી દેજે નહીં તો બંધ કરી દેજે
પોઝ કઈ થતું જ નહીં ઓકે હવે થઈ અરે
1 મિનિટ OBS ઓપન કરતો સ્ટોપ રેકોર્ડિંગ નહીં
stop नहीं ना so we are running the server at 8000 port and the client at local host with server port 8000 with RTP packet port 5000 and the file name. The first we run the server, and second we run the client. So it pop up a window. Now we make a setup request to the server and it did give me a message reply. Now if I play, then it workingly fine. If I pause, then it's also working fine. Then again play, it works fine. Pause, work fine. Pause and the tear down, the connection has broken, so it's all working fine. So now we move to the working of server. So it's a class server. Now the server port, we uh, we take the argument from the terminal and server port. Now we create a server socket. We bind it with the server port 8000. We listen to the maximum of 5 clients. Now we will make a infinite loop which will accept the request infinitely. There's a client info, then client info socket accept. This accept will return the socket address which the client will try to connect with. Now server works run, and now we will run the server. Okay. So now we move to the server worker part. So these are the variables for setting up RTSP variables. This is the defining status. This is for HTML status request. Then this thread is for, this thread is for each client we are making the thread. For each request we are making thread for new client. So now in the receive RTSP request, first we will get the socket information from the client. So now we have the client socket information. Now we will now we will get the received data from the client, which has the maximum limit of 258 bytes. So if client sends the data, so we print the data received and the data decoded. So this decoded form is for string to binary form, and then we will transmit that binary data to process RTSP request. So now for the process RTSP request sent from the client. So we will first uh, so first the client will send a request. So that will be this format: setup movie.jip 1 RTSP 1 RTP UDP 500. So this kind of information, so server have to process. So first we split it. So request, it will split the data from the RTSP request which is coming from the client side. Then we will split the file name, which is this one, movie.mjpg. Then if the request type is setup, so for understanding request type, we will go to the question PDF. So here first we will be in initial stage. Then if the client makes the setup request, then we will go to ready state. And if client again make play request, then we go to ready to playing. Now if a client make pause request, then we go for playing to ready. And if we are in ready state, and if a client make tear down request, then we will go to initial stage. બરાબર so if a client make setup request, then we'll go for, and if its state in server side is initial, then we will processing status. And if we try to send the video stream data from the file, and we will update the state from the ready. So for the session, we first update it from some random numbers, and we will reply the client that uh, okay status, and with sequence number 1. And for the ITP and UDP port number, we will extract it from the ITP port from the client side. So if a client make the play request, so we will check the if server side state is ready. If it's ready, then we update it state for playing, and we we now send it to the client socket for that movie. And this is for pause request. If if client make pause request, and if the initial stage is playing, then we will pause it, and we will set our state to ready state, and we'll reply client to this OK 200 status and with sequence number 1. And for the tear down request, as usual, if the client make a tear down request, then we will set it, then we will process it, and we will set event to set. This is for the stop the thread that will receive the data from the server. So now, we move to send RTP. So the send RTP's job is to send RTP packets over UDP. So we will have the infinite loop. So first we will wait for some second. Then if the client make the request pause or tear down, we will stop the data sending. And now we will send the data frame by frame to the server. So if we succeeded in sending the data, we'll have to update the frame number. So we'll update it frame number by client info's video stream and frame number. And we will try address and we will try to send it over the client socket address, the client port address, and we also send the make RTP, which is the RTP request header. We will also send to the client. So for this function, we are only making the RTP header. So this is all the initializations. We will have RTP packet to RTP packet. Now we will encode. Now we will create a header for RTP, which will be the function encode. So this encode is defined as follows. So as I said, this encode is in RTP packet. This encode, it's a header, and header is like this. So this is the header. This is the 32-bit by row, and there are 4 columns, but we do not consider the last column because in our case we don't have to. So this is 32 bits and 3 columns. So there are so this is row wise. So the entire row size is 32 bits, means 4 bytes, and there are 3, and the row is 3. So there will be 4 into 3. So there the total header size would be 12 bytes. So now we move to the code. So here we define header size as 12. And in class RTP packet, we define a header with byte array. This is the class which defines a bit array, which defines a bit array with header size of 12. So this byte array, if it's a 12 size, so each block has a 8 byte space. Sorry, 8 bit space. So for version info, we left it into 6. So why we done this? Because if we look at the header, the version info is in the header's first block, and it requires only 2 bits. So if we calculate it from this 7, we left shift it into 6 times. So it will be here. And as usual, this padding, as we can see, this padding is required only 1 bit. So we will right shift it into 5 places. And as for extension, and we move extension to the left shift 4. So it will be at this position, and the remaining bits will go for CC. So this thing, we why we do this, or to append the new data to the previous data. It's just a OR operation for that. So now we move to the next header, and it has in diagram the maker part. It only required 1 bit to denote it. So we left shift it to 7 places, and for remaining places we just put it PT, as we seen in the diagram. The remaining second header PT is the remaining bits over here. And for the next and the for next header, we we have to denote a 60 bit sequence number. So first sequence we shift it right to the 8 places, and then we append as usual sequence number. And for the next 32 bits we have time step. So first we will right right shift it to the 24 bits, because why we do this, because all the block which is in the header, it's only have 8-bit length. So we have to put the data in that manner. First we have to fill 8-bit header, then we have to move to the second block, and then we have to do that. So that's why we first timestamp. It's a 32-bit number. We will right shift it to the 24 places, and we end it with this ff means there will be 48 and 48, means there will be total of 8 ones in this number. So why we end it, so we only have the number after 24th bit. So it will be have all the zeros before 24, and after 24 it will be all ended with 1. And as usual, the 24 bits is it's in the timestamp. Then we move to next then we will move to the next 16-bit. Now we will again right shift it to 8-bit, and we will then append it just time step. And as usual for SRC also required 32-bit representation in header. 32-bit representation in header. So we will first go for the last bits, and we will append it to the header. Then we will move to the next 8 bits. Then we will again move to the 8 bits, and then we will just go for the whole thing. And then we will get the payload from the argument. So now we move to the decode part. So the first we encode the entire header in this function, and now we want to extract the information one by one. So that's why we will decode it. So we move to the version. So this version will return the RTP version. So what we can do this, what we can how we can achieve this. So we just right shift it the header 0 to the 6 places. And why we do this, because if we see the this header diagram, first 8-bit is denoted by version, payload, extreme, CC, so that kind of thing. So if we have to extract the version info, which will be in first 2 bit of the header, so we have to shift it right side to the 6 bits places.
Similarly, this
And similarly for this sequence number, how we can extract this? We just left shift, we just left shift it to the 8 places, because for inserting we right shift it into 8 bits places. So for extracting, we just reverse it. And for the time step, we also do the same. And then play.temp info, we also get payload and get packet, we also did the same. So now this is all for the header encoding. We completed the encode function for the ITP header. So now we move to the server worker, which you call this encode function. So we will just reply, and this reply RTPS is reply RTSP is for sending the reply to the client, like okay, then all the status which we have to uh, uh, send to the client for the reliable connection. And if we found any error like file not found and connection error, then we will print this. So now we will move to the client launcher. So in the client launcher, we'll have the server address, which is the IPv4 address of the server, server port, which will in our case it's 8000, which we denoted earlier, and RTP port will we can assign it any number greater than 1024, and the file name, which we have to request from the server side, we have to give the file name also. And this is just for the GUI purpose. We the tinker, this for the just tinker GUI interface. Now we will go for the client. The client is this one. So we will pass the parameter to the client root, the server address, the server port, the ITP port, the file name, because this client is a constructor. So now we move to the client, which we have the class constructor like this: self master, server address, server port, ITP file name. So in the client class, we have this initialization of the state. We have this setup, play, pause, and tear down for the client side. And now we define the all the constructor for the client side. So we will first assign the server address, which will we gave to the terminal at this point, and then server port as usual we derive it from the terminal, ITP port as above, then file name, then we will just initialize by the all zero, means the RTSP sequence number should be start at 0, the session ID will be start at the 0, then the request ID will be -1, and all that. And now that we established a socket from the client side, this RTP socket is the client side socket. So this wage create waits function is it's for the building GUI function. So this is the button information, this is the play button implement, the pause button implementation, a tear down, the label of the movie, and all that. So this setup movie is for the setup button handler, which you seen in the demo part. So if the state is initial, then send RTP request set setup. This request will be sent to the server, and server will reply accordingly. As for this exit client, the exit request is also the request which we have to give to the server to close the connection. And and is it's and in when this exit client function is called, we request server as tear down request. Hmm, bro? Now for the pause movie, the pause button handler, if the state is playing, then we send a request to the server that we have paused the video, and this is the line for that. And for the play button, it's also the same. We check the ready state. If it's ready, then we will make a thread for listen to that server side, and we will make a thread that, and we will play the event thread event, and then we will send a request to the server as play. So this is the listen RTP function. So we will receive the data from the client side, from the server side, from the maximum of this many bytes. If we receive the data, then we will call the RTP packet and we will decode the data. Means we will get this header information if we receive any data from the server side. Then we will check for the current frame which is playing on the client side, and we will update it. We will update it, that frame number, and if and as we will stop listening upon the requesting pause or tear down. We will check if the is state of play event is it true or false. If it's true, then we will break, and we will go for the right frame. And in right frame, we are writing the binary file. We will open the that file, and in the format of uh, byte file, and we will write the data in the right frame, and we will then return that cache file name. And for the update movie, we open that file and update it to the GUI frame. And for the connect to the server function, we have also seen in the constructor that we have to connect to the server. So this is the function for that constructor. So in the connect to server, we connect to the server and start a new ITSP and TCP session. So for we establish a new socket, then we connect it to the server address and a port address to, and that's how we connect to the server, and then we will send the RTCP request to the server side. So here this diagram is implemented. So we can see that if the request code, if this client will make a setup request and its state is initial, we can see that its stage is initial, and if client make a setup request to the server, then it have to go to ready state. So as you can see, as we can see that the request is made here, and we have to then update it as request status to setup. So for the play request, first we made the play request and we check that if it is in already in ready state. So we can, so we will play the video. So for that we will make the request play, then we will send it to the server socket, and we make it request to the play. And for pause, it's always it's is in the like diagram. If we are in playing and if server make a pause, then we have to pause. So if client make the pause request, and if my state is already is playing, then we have to pause the video. So we send the request pause to the server, and server then reply us with the pause. And for the tear down, as same as above. And now for the receiving RTP reply, we receive the RTSP reply from the server side. So we will at most receive from the server this many of bits. If we get any reply, then we pass it to the purse reply. This purse RTSP reply is just to assign that data to the uh, our session ID variable, then a ready state, which kind of state we are in from the server side, and state ready, like that. And if the request sent by the client is tear down, then we will just close the socket from the client side, and that is. And for the open port RTP, we open the port, we bind the port to the server address and RTP port. So we bind the RTP port with the server address, which is in our case IPv4. And this handler is for GUI handler on explicitly close the GUI window. So this is just for the tinker side.
And as it will be about your
So now we move to the client launcher. So now for the video stream part, here we just get the next frame from the file name, and we update its frame number, and that's all we are doing. And now for the client request, we first make a request to the server like this format, and when we set up it, we get the request like this. And when we are play, we get this sequence number like this format. And when we request the pause request from the server, it replies as this pause. So for the client side, first we make a setup request as follows. So in the server side, we receive setup request as follows. Now, if we make a play request to the server, we get the sequence number like this, and from the server side, it receives the play request like this, the processing play, and then after, if we request a pause from the client side, in the server side, we get the message this pause and processing as pause. And if we request the terminate down, then from the server side, it replies as processing terminate, and it's terminate the process. So that's all from our group TG7. Hope you enjoyed it. Thank you.